This is a demonstration of 41439. The item is supposed to have a problem with loss of audio associated with the physical mounting of the volume control, and it has not occurred here. So what I'm going to do is troubleshoot it again, this time make a recording. And what we need to do is keep the lights down low, because what we're going to observe is the output on this device here. I'll zoom in on this. This device here, there we go. And if we get the light off it, we can see better. There's two traces. The upper trace is going to show the left channel audio output. The lower trace is going to show the right channel audio output. And this is a much more revealing test than our ears. And our ears would be useless on this type of test over the internet. And what we're going to find, I think, is what I found the first time, is that the item does not exhibit a problem. So what we're going to do is test it in 3 different states. The way it came in with the volume control tightened. Then we're going to loose it to the point that it wobbles, because that's what the customer said. And then we're going to actually remove the board, and more than likely it's not going to show a problem, as it did not the first time. Okay, so what we're going to do is we obviously can back this out real quick, just so we get our bearings. This is the item. I'm going to turn it on. And what we're going to do is feed a sine wave rather than a dynamic sound like music. We're going to feed a sine wave so we can observe any problems with this wave as far as noise, distortion, dropouts, things like that. We're going to feed it in, and it's going to sound like this. If I turn that up too loud, it's going to saturate the microphone and its associated circuit, and the sound will be distorted. But that's what it sounds like. And we'll be able to go with the balance left and right. And so what I'm going to do now is take camera and go back to our oscilloscope and see if I can get the device right above it, and also, which is a distortion analyzer level meter. That's this black device there. And if I back this out just a little bit, we can probably get them both. Okay, now we're going to get the light off so we can see the scope. Okay, now what we're looking at on the oscilloscope, I'll turn the volume up, is, and you know what I'm going to do? I'm going to go into what we call a dummy load. The dummy load takes the place of the speaker. It stresses the item exactly the same as a speaker would, but it does not drown out my audio or hurt my ears. Okay, so what we're going to do is, the volume control is on tight, and I'm going to go to the balance just to show you. When I go to one side, the upper display is there. When I go to the other side, the lower display is there. So there's our right channel, there's our left channel. We can vary the volume level. And what I'm going to do is hit the item. If there's a loose connection, we will be able to see it in the display. I'm actually going to pick the item up and drop it a few times, and nothing is occurring. So what I'm going to now do is pull off the knob. I'm going to loosen the volume control. This, I believe, is how the customer started this adventure. Now it is loosened, and let's get this off of here. And let's bring the volume back up a little bit. There we go. And what I'm going to do now is wobble the volume control. You may be able to hear that. Notice both waveforms, left and right, are fine. I'm putting my hand behind the front right now, torquing the circuit board that it's mounted to, and moving the cables that are associated with that board. And as you can see, neither waveform has a problem. I'm going to go to the balance. There's our left. There's our right. Now what I'm going to do is I'm going to have to turn the item off because I'm going to actually remove the yeah, but we're doing something. Hang on, sir. Okay. The interruption is over with, and we were interrupted when we were going to stage 3 on this, where we're removing the board, which this would be the most unstable mounting of this device. And if it holds true to form, as the first time I looked at it, it's also not going to exhibit any problems. So I've removed the nut. And I turned it off, so the power is off, so we don't damage anything. Now the board is in the back, out in my hand, and we're going to turn this back on. And here we go. So we're going to turn the volume up. And let's get the light off the scope. There we go. The light is off the scope. And I am moving the board in my hand. I'm torquing the board. I'm flexing the cables. Nothing is occurring. I'm tapping it with my hand. Nothing is occurring. This item either has an intermittent problem, which is not occurring now, or the problem lies elsewhere in the person's system. But this item is not failing. I'm going to go to the balance control. There's the left channel. There's the right channel. And I'm going to put it back together. I have to turn the power off to do that. What a sponge. Okay. We put the item back together. The volume control is tightened nicely. It's not going to move. Let's turn it back on. All right, let's do our testing again. Turn the volume up a little bit. There we go. Let's bounce this around. I'm actually picking the front of the item up a couple of inches and letting it fall on the workbench. No problem is occurring. I've got my hand in the back. I'm torquing the circuit boards. No problem is occurring. I am moving the cables. There is no problem. There's the left. There's the right. I'm going to turn the volume down just a little bit and leave the dummy loads and go back to the speaker. Alright, this item is not exhibiting any problems here. That's the end of this video.